Hi, I'm Kevin. Here we have a multi-sim circuit. Starts with a function generator, goes through a couple of resistors, and we're going to measure the voltage across the source. So, starting with the multimeter. Make sure the positive and negative are on the right side. And we're going to hit run. Now that we've taken a sample of this, the source, we're going to measure the volts peak to peak, get our cursors in the right spot, and that'll give us a measurement of 17.9. And to get the RMS, we can either check the multimeter, and that gives us 6.36, or we can plug it into the equation, divide it by 2 and multiply it by 0.707. That also gives us 6.36. And to get the measurement of the period, we just capture one cycle with the cursors. And that'll give us 1.25. That's in milliseconds. And in order to get the frequency, we divide that by 1 and multiply it by 1,000, and we get 800 hertz, which is cycles per second. And that's how we do it before the resistors.
Hi everyone, Jordan. In part 2 of our Team AC circuit video, we're going to be measuring first the voltage across our R2 resistor by first connecting our cables here, cable here. We're going to run our simulation. From here we can see that we get 4.75 volts.
This one right across the channel.
Next,
We did have
we're going to connect our oscilloscope so that we can get our other measurements.
That way, or you can count the boxes.
let me do them again.
And we're going to check our measurements
Yeah,
here.
that would probably help, right? Let's try that again.
Okay, got it.
Let's try that again.
So first thing we're going to measure is our voltage peak to peak. You can see down here that we're getting 13.43 volts. And then to get our RMS measurement, we're going to take our peak to peak voltage, divide it by 2, and multiply it by 0.707, and we'll get 4.75. Now our period is going to be 1.25 milliseconds. And to get our frequency, we're going to take our 1.25 milliseconds. We're going to take 1 and divide that by our period, multiply it by 1,000, and we get our frequency of 800 hertz.
My name is Jerome Clark. This is Group 4's breadboard part. We've set it up for voltage across R1. Right now we have measured the voltage peak to peak, which is 18 volts. The RMS is 6.36. The measuring period is 1.24 milliseconds. Measurements of the frequency is 1 over 1.24 milliseconds times 1,000. We got a frequency of 806 hertz. Sorry.
Shows that on here.
On here, you can see all the calculations that we've made. Actually, it's come out to the correct numbers that are on here. So if we move it, oops, wrong one. Trying to get this.
That's not it. No? It is.
Okay.
So this is for the first part of the measurement. You have T1, which is should be right here. Then we have T2. If I move over, it should be at 1.24 milliseconds. So this is how we came up. This is how we checked our answer to make sure that it was correct. Okay.
My name is Conroy Daisy, and we're going to be going over how the circuit is set up and also measuring across the second resistor. Alright, so we're starting here as well. This is coming from our function generator, this probe. So you have our positive, we have our negative. Then also as well, we have our first circuit, our first resistor, and then we have our second resistor. This probe right here is going to be measuring across the voltage of our circuit. This probe is going to be actually measuring across the second resistor. So going over to the machine.
Somebody speak for me. I'm not
Now the first measurement we're going to be doing is across the peak to peak. We're going to measure for the voltage. Right, so as we have it here set, we're getting 13.2 volts. Right, so now to figure out the RMS, we have it also here, which is going to be 4.85 volts. Alright, so now we're going to be measuring for the period. And for the period is what we're going to be getting. We're going to first set our cursors here and here. And that gives us 1.28 milliseconds. Alright, so now to go ahead and figure out the frequency, we go back to our screen here. And we get a frequency of approximately 806.5 hertz.